Okay, good afternoon, everyone, and welcome to our second webinar. We're very pleased to have you. Just to give a little recap of yesterday, we had ACS2023 University from Ghana, and they were displaying their sensors. They have microbial-based sensors that enable one to detect the rate of deterioration of building materials. And part of that, a lot of the questions centered around whether or not those sensors would work indoors, because right now they're being used outdoors on coastal barriers. They have not tested those sensors within a building setting, but both ACS2023 University and the literature that we've read points towards the fact that the sensors are, the bacteria in the sensors are triggered by water, humidity conditions, and by mold. So with that, we're anticipating that it would be possible to have the sensors work equally well inside and to figure out what the rate of decay within a building is. The reason that we're talking so much about water is because we are also showcasing what to do in the case of flooding. And one of the things that's going to be happening with climate change is the increase of floods. You also, with Pakistan, the floods that we had, even here with Lake Naivasha, and the flooding around Lake Naivasha, that was the tourist area was totally submerged. And unfortunately, those kind of events will increase with climate change. And as they increase, we still have the challenge of what to do with our human habitats. So the presentation from Chorus Architecture focused on looking at how to build a floodable city. Floodable cities being in the literature in terms of being able to have absorbent materials. And we had a lot of that in terms of permeable surfaces and the like. So one of the things that we know is that kind of technology tends to be more expensive. And we're trying to figure out effective solutions that we can use to keep the permeability of surfaces low, but also to be able to safeguard humans from the effects of flooding. So the solution that Chorus Architects came up with is pretty ingenious, which is to build cities on an elevated platform. And with that, then the ground level is sort of what you would think about as the first floor elevated. And you have the water, if it floods underneath, then the city or the neighborhood is still safe. This will be built on piers. Now, today what we're going to do is go through and explain, everybody's talking about greenhouse gas emissions. And sometimes in the discussion, there's the public discussion, there's not a recognition that these greenhouse gas emissions are chemicals. And as chemicals in gas form, they interact. When it's hot, the prevalence of these emissions will have one effect. When it's colder, those emissions change. They also interact in the spaces within the buildings with the different materials that are available, and they interact with your body chemistry. So those are issues that we wanted to raise sensitivity and awareness about. And that will be the first presentation you're going to hear from our managing trustee, Professor Shemwandiga. And let me cue up the presentation. Gone into presentation mode. Sorry about that. Okay. So with this, I will hand it over to Professor Shemwandiga to begin the presentation. Thank you.
Good afternoon, good evening, good morning, wherever you are. Thank you very much for giving me this opportunity to talk a little about greenhouse gases. But I want to start my talk by saying that we humans, nature has made us in such a way that we are a perfect combustion engine. We emit carbon dioxide and you don't see black smoke. Or we breathe out carbon dioxide and there's no black smoke. It's all white. And of course, pass urine as another. And it's just like when you have a perfectly tuned motor car. When it runs, you don't see the black smoke. You just see very little white smoke and water coming out. That is the combustion engine. And that combustion engine gives us energy. It takes us places, just like the car takes us places. And what we need to understand is that when we breathe in 78% of oxygen, nitrogen, 21% of oxygen, and very small quantities, about 1% of other gases. These other gases are the ones which we call greenhouse gases, and they're composed of carbon dioxide, nitrous oxide, sulfur dioxide, and many other particulates which we emit out. Now, let's look at how nature does it. It is so simple. It uses a small molecule in the blood cell, hemoglobin, and that small molecule contains iron. And that's why the blood cell is red. And that iron binds oxygen, and the blood takes it to where it is needed for combustion. The same way that the trees use a small molecule called chlorophyll. And the chlorophyll also combines carbon dioxide and takes it to where it is needed and releases it to build the green plants and the green mass. These two actions are similar in nature, and they operate almost as equal. When we breathe this chemicals. There are no side effects. But of course, nitrous oxide, when combusted in the motor engine, nitrogen when combusted in motor engines, will give you nitrous oxide. And the nitrous oxide will interfere with the binding site of oxygen in human. And when it does that, then the combustion engine stops. But that interference of nitrous oxide and sulfur dioxide, particularly in the atmosphere, brings about something which is very unusual, particularly in the atmosphere. They produce something called free radicals. That's an element with one electron, free radicals. Nature hates free radicals, and it works in such a way that it destroys wherever free radical is done immediately. And for that reason, we are saved by nature from using free radicals to destroy our system. But then we humans like luxury most of the time. When we build houses, offices, and things like that, we like to have carpets, soft carpets. And we like soft sofas, and things like that, which makes us look great when we sit in our office, which is well padded. But these sofas and chairs and what have you, and paints in the wall have additional chemicals which sometimes affect us most profusely. Particularly, there are some chemicals which we call PFAs, or polyfluorinated substances. There are 8 carbon atoms. These PFAs interfere with our system, but you most likely will find it in buildings. You won't find it outside of the buildings, in buildings and in air or in water. I've listed some of the effects on the board, which I will not go through, but the fact is that they interfere with our natural breathing system and living system and produce diseases that we do not want. Then we have also other chemicals which also work that way. Nowadays, people like antibacterial microbial soaps, antimicrobial solvents, and things like that. And again, you use these antimicrobial substances at your risk. They are not safe. And again, they interfere with our body system. And when we use them, we should be aware that our body system will be affected. Nature doesn't like them. But we humans, through greed, think that when we bring something like antimicrobial soap, people will buy it. You buy it at your risk. The next chemical that I want to talk about is the flame retardants. The flame retardants are everywhere, in the walls, in the furniture, in the sofas, and everywhere. And these flame retardants, again, interfere with our body system. And they again affect us wherever we are. And we are advised not to use flame retardants as generously as they are being offered to us by commercial farms. there is the next group of chemicals, which are again found in paints. And these are bisphenols and phthalates. Bisphenols and phthalates have been proven to be endocrine disruptors. And when you have them, you find that the sperm counts goes down. And some often we see in fish, we have fish which are bisexual. He has both the male and the female parts. But naturally, these biphenyls are man-made. Bisphenols are man-made chemicals, and they are spread everywhere in the environment. And again, these are chemicals that we have to look for and count for them and see if we can discourage their use. The next type of chemicals which are very well spread about is the solvents. We use solvents. Nowadays, people like solvents. You wash your hand with the this disease which came about, COVID things, and you wash your clothes with some organic compounds that you are going to, you think that will make you safer. But solvents are everywhere in the environment. And these solvents are also not good. They may go in the air also if they break out. And for that reason, it is not useful to have a lot of solvents around you as a chemical process. And lastly, I want to talk about the lead, the metals. There are three metals which are very, very useful. One of them is lead. The second one is mercury. The third one is arsenic and cadmium. They are useful in industry. We had lead gasoline until recently in our petrol tanks because it helps the burning of the gasoline. But now that one is substituted by other chemicals which enable the burning of the gasoline easier. Mercury is used particularly by ladies for skin brightening. You want to change your skin and you use mercurial soap and mercurial creams to lighten your skin. At the same time, when you do that, you are killing yourself. Cadmium is also an industrial chemical, just as arsenic is also an industrial chemical. And their prevalence in the air or in the water also give us toxicity that inhibits our normal biological natural system, which has started with that system of our body, which works fluently and without hampering, is interfered with when we add these metals into our system. And for that reason, I want to say that in Kenya, we have all these chemicals everywhere, and we have detected their presence. But the most important thing to realize is that Kenya is not as polluted as other countries. And most African countries are not as polluted as the industrialized or near industrialized countries. And for that reason, we have to remember that we are talking of air emission. Africa is known as the Black Continent. When you fly over Africa at night, you don't see many cities, you don't see many towns, except when it's the season for grass burning. When the grass is being burnt, then from the air, you see a lot of light in the grass burning areas. Grass burning is done for many reasons, but one of the most important one is the killing of the ticks so that the new grass can come up and we have fresh grass for the cattle and the animals. It becomes very important for us to look at our government buildings. We are not central heating our buildings, so you won't find a lot of CO2 inside, but we have a lot of human traffic in these government buildings. And when we are going to look for these chemicals, we will be looking at the remains of human activity, the remains of paints, the remains of carpets, and things like that. These are the things that we are going to measure in our buildings. There is another thing that we like very much, is that we like stones, building stones. And some of the stones have radioactivity properties. So we will also try to look at radon, the radiative element radon in the buildings. It builds up when the doors are closed, but when the circulation is open, then the level goes down. And all of this, ladies and gentlemen, are chemicals that are facing us, and we have to know their quantities, we have to know where they are, we have to know how to reduce them. And with that, I hope I've given you an idea that chemicals are present everywhere. They are present in the air, they are present in the water, they're present in the soil, and we have to look at them. Lastly, trees. As I started by saying that trees use chlorophyll to bind carbon dioxide, and they breathe out oxygen. And this is the lung of the world. So the more trees we build, the better we are going to be, because we will have more oxygen available for us and for our system, our efficient natural combustion engine in us. Thank you very much. as an experimental chemist, I would say nothing beats the actual experimental analysis. We still need to get that one because those softwares are based on averages of the experimental analysis. Now, softwares have advantages and disadvantages. They make the work easier, and you can move on and do a lot of estimation. But you have to always be careful that you don't have the idea that what you have measured by these software programs are the true value. We still have to look for the true value of these chemicals. And there's nothing that beats a true chemical analysis. Yes, you can use them after you've done calibration over and over time, and from time to time, you do time series calibrations so that the data you get is acceptable. Time series calibration, not NSE. Time series calibrations. There's certainly going to be differences because in nature, we are bequeathed with these differences. You will find that in colder climates, the emission may be subdued than in the warmer climates. And therefore, you must be able to anticipate and see the data that will give you the gap between the difference in continental or environmental factors that are making the air behave differently. Air behaves differently as a turbulent, and most of them influential factors is the hills, the mountains, the ocean, and the valleys. And the movement of air in those areas are going to be different. And of course, the temperature is also a different factor, because when you have cold weather, I'm not saying that you don't have cold winds, there's still some cold winds, but some chemicals may have frozen and fallen out because of the temperature. PFAS are harmful at any stage. There are many governments are trying to do is to eliminate PFAS from use anywhere, and we have not started in the continent. No, the radioactivity is inherent in the material. So it is only when you use materials that are radioactivity that you have the emission of radioactive waves or electrons or radons, protons, and what have you. So we need to always check the materials that we are using and make sure that they are not radioactive in themselves. Certainly, the soil that you use to build that house must have had some radioactive materials. And that's the reason why it doesn't go down. The second one is that the house may not have enough breathing points. You not have big windows or circulation point. The air doesn't circulate well. So the best thing is also to make sure you have windows or doors that would admit enough air into the house. The fact that you are using mud and you have with it MUD, yeah, you have with it radioactive materials, it's very difficult to remove that except to find a different earth which is less radioactive.
How, as designers, architects, and planners, you start thinking about the siting of where buildings are located, the importance of testing prior to construction, and looking at the different types of risks in a more comprehensive manner. We're going to now hear from Zain Bawa from Pakistan, and making sure he's here. And he's going to talk about sensors. And the reason, yesterday we had a presentation from Ashesi University, Elena Rosca, on microbial sensors. And today we're just talking about the regular types of sensors, because not necessarily all sensors can be microbial. And the reason is we need, like Professor Wandiga was saying, we need time series data. We need more data points. We need more tracking and more, not only data points in terms of buildings and locations within buildings and outside of buildings, but also the time of the day and the time of the week and time of year and different conditions. So having that data accumulate through IoT sensors would make things a lot easier. So let me switch over here. Okay, Zain is not yet on. Hold on. I will pull up his slides though, so that he at least have that. So while we're waiting to see if Zain connects, he's in Karachi, Pakistan. So I don't know if there's a power outage. You never know what could go on with in terms of being available. I'll just go through, start going through his slides. Yeah. Sorry, I need to exit here. So we have the trying to the right place. Sorry, at least the right slide is showing on the camera. It's not showing on my computer. Here we go. So basically, what sensors do is you look at ways in which you can capture a low-cost IoT and link that data to artificial intelligence algorithms. We have here within Kenya, we ourselves at CSTI did a trial with water sensors. That was about 2 years ago. The network is called SIGFOX, SIGFOX. And what we learned was, I think the most frequent data you have is hourly. In some countries, they allow minute-by-minute updates. In Kenya, your sensors can update hourly. The reason that is significant is early detection. So if you had a gas leak, for example, a factory that's producing mercury, to be able to have that minute-by-minute detection is critical in terms of containing the spread of those emissions. And hourly might be a little too slow, but it's definitely better than catching those emissions 2 days later or 3 days later. And so when you're looking at the ability to link this to AI, you're also looking at artificial intelligence, being able to think about how one is predicting climate conditions that could trigger a release of chemicals. And by that, I mean, we're getting a lot of freak storms. So it's not just the flooding that could, if you have a chemical plant and it gets flooded and those chemicals leach out or get exposed, but lightning, some lightning does hit buildings. And you have, if you have a heavy lightning storm, you want to be able to start predicting those conditions in the AI to be able to have a system that detects or anticipates in advance if you have a risk at a particular location. So that's the early warning system component. Data-driven decision-making. Like we were saying before, when we're trying to figure out whether we have embodied emissions or we have a life cycle, end of life cycle, and if we're getting any emissions from the radon, all of the remedies of these emissions are expensive, and we tend to need to prioritize. And by that, I mean to be able to say, if the number of, there's a high radon, but there's no human or wildlife activity in that area, it doesn't necessarily have an mitigation or intervention priority versus if we're having a mercury gas leak in the middle of CBD, we know we need to deploy resources and money to that very quickly and immediately. And so not only data-driven decision-making, but also resource management. And so that's on the mitigation side, which is the most expensive part of climate change actions. But then on the public awareness side, to have behavioral changes. And by that, we mean either stop using certain types of chemicals or to be able to tell people, request people if they want to relocate, or be able to have people connect in different ways, or just collect in terms of collecting data. And I see now Zane has managed to join us. So Zane, we're about on slide 3. I'll let you take over on this slide.
Hello everyone. Can you hear me?
Yes.
Okay. I thought the previous session was going on. I was just finishing a meeting. Just joined.
No problem. You can continue.
All right. Shall I share my screen, or will you share your screen?
Hold on. Let me stop. Go ahead and share.
Sure. Can you see my screen now?
Yes.
All right. So I just saw that you went through a few slides, but I'll jump to that slide. Just a bit of introduction. This is Zen. I'm a CEO of ITSol. Previously, I have been in the technology industry for the past 7 years, working with various clients. And for the past 3 years, I'm like part of this company, and I'm running this company. What we do is we provide low-cost IT solutions to industries, work with various clients, some of the government projects, and some of the agriculture-related projects. So in the past 3 years, we have worked with malls, like the urban centers where they deploy IT sensors. We have worked with modern farms, working on how to save water resources, various factories working on how they can lower their energy usage or energy consumption. So like I've been through a lot of these because I'm part of this company where we deploy low-cost IT solutions, because working in Pakistan, in the initial investment, people don't do a lot of investment. So the actual change was the low cost ID sensors that came in. So it's quite related to what I work with, and it's quite close to my heart, the topic. So what I did was just a bit of introduction of environmental surveillance. I think Cecilia has already gone through what environmental surveillance is and how low-cost ID sensors are changing it. So I'll just jump to the slide she was going through. The major component of this talk, what I'm going to give is environmental surveillance. What is it about, and how governments can create or change something using technology, what IoT sensors, what their role would be in changing how we monitor our environment, plus AI and artificial intelligence, how will it play a role in allowing us to make informed decisions. So one of the major component is monitoring, of course. She has already gone through it. Next is what makes this monitoring available, or what allows us to do this monitoring, which was never possible before, is the low-cost IT sensors. We get real-time data collection. We'll be able to do remote monitoring. We have a wide, diverse range of parameters. Like one IoT module, if you are deploying a custom module, you can, at one end, you can do all the things which are related to atmosphere, like the PM2 or the ozone or the carbon monoxide or with the same module, you can do whatever is happening inside water. You can do aquatic parameters like with the water quality, turbidity, and everything. So within the same module, everything is possible. So it's quite diverse, and granularity and precision. IoT sensors, like let me give you an example of a mall which we were working a few days before. What they do is they are monitoring air quality, they are monitoring temperature and everything, so that they can make sure their energy usage is not very high, right? So instead, initially what they used to do was they had this handheld sensor. Every time, like a few hours, their person will go to the specific duct, monitor temperature, come back, right? And you don't know if he actually went there, or what actually is the time interval that he has to go, what time is better, like the footfall is higher, so that he has to monitor temperature. Like all of this can be covered using the IoT sensors. Like you can set the intervals, you are made sure that the sensors are installed at a specific location, and you can take data driven insights. Like you can, all of this data will make data driven insights possible. And one of the major thing that the government and citizen science can do together is the collaborative monitoring. Once you have these IoT sensors involved, like let's say sensors are imported by the government, or the sensors, the sensor modules, they are developed by a lab in a university, right? So the government bureaucrats, the researchers and the students, all of them, and even the normal citizens, they can collaborate on these IoT related sensors data, make decisions and take informed decisions, plus take ownership of their environment and surroundings. Okay, so once you have all this data, we should acknowledge that AI has made a drastic change on how this data allow us to make informed decisions. You can process a lot of big data in real time, identify patterns which were not possible before. Like you sometimes you are shocked that there are correlations that seemingly they look unrelated. Like the variables, you will say like they can't be related, but with the help of AI, with the help of pattern identification, you can take decisions on like seemingly unrelated variables. You can do predictive analytics because you have this historical data lake. Citizens are contributing, all these IoT sensors are contributing. You can run through algorithms on these data and do predictive analytics. Plus, there is anomaly detection in real time. Like there are sensors, these are still low cost sensors, but they can take informed decisions on their own. The microcontrollers are now so powerful that they can take informed decisions on their own. They can send notifications if there is a trend or there is an anomaly that deviates from the normal environmental conditions. You can get notifications. Plus, with the help of AI now, if you have IoT sensors, your citizens are contributing through IoT sensors, plus through data portals. Plus, you have satellite imagery, and you have other sources of data. You have historical data. All of this data can be fused together using the technology, and you can take informed decisions. Policymakers can make informed data-backed policies. And all these AI algorithms, you know that they can be adapted, they can be retrained, they are already retraining, or they are reinforcing models. So they have drastically changed how we used to make decisions based on data. Okay, so now how the government can participate, or what should the governments do? Forward-thinking governments, like you can talk about Singapore, you can talk about Netherlands, you can talk about Denmark. They are recognizing the potential of IoT technology for environmental monitoring. They are investing in IoT sensors. We'll talk about a case study in China, that how are they deploying IoT sensors to make informed decisions. Plus, what governments can do, which normal organizations or which citizens can't do, is building a data ecosystem. Governments can provide an ecosystem where individual organizations, like let's say if the power sector is distributed, the power organizations can contribute to the ecosystem. On the other hand, the researchers can contribute to the system, the agricultural department can contribute to the system. So governments can create this umbrella or the data ecosystem, which is a central data ecosystem, and different organizations, they can participate, they can, and also the researchers can utilize this repository to make decisions and to make innovative solutions, or for, let's say, for the agriculture department to come up with the policy that will help the farmers, plus help the citizens too, and plus help the environment. The responsive policies, like once you have this data-backed ecosystem, your data is coming in real time, your policies will be responsive. And also with this responsive policies, the citizens will have an idea that the government is thinking about us. They will take the ownership, and they will, like, let's say if there is a government program that every house needs to install this small IoT sensors on the rooftop. And if they see this responsive policy that this is making a change, they will actively participate in it. Plus, governments, like normal organizations, they can't do like global partnerships, they can't do global events, but with the small effort, government can make a huge difference with global partnerships, like forging global partnerships to share data, or calling out international researchers to come and see how the government is using or making use of the data. Plus they can you can say create a knowledge base for international environmental. Sorry, I had a call. They can make policies, or they can create a knowledge base for the international. I'm sorry, I had a call. Just a second. So I was talking about how governments can create a change. Plus, I was talking about the collaboration with researchers, with students, with the government organizations. All of this can be made possible with the government initiative. So government is more towards how they will change the policy, plus how they will involve international organizations. And one important thing that the government will do will be, of course, investing in the technology infrastructure, investing in these IoT solutions, plus investing in the infrastructure that will allow the IoT, like the stronger 4G networks, stronger fiber networks, so that the IoT solutions can make a difference. So on the other hand, the citizens, what the citizens science will make, or the difference the citizen science will make. It is a transformative approach. Like a lot of it has happened in different countries previously. What it will do is it will democratize data. Everyone will participate, everyone will take ownership. Plus you will have massive amount of data coming in. So it's about numbers, like huge number of people, they will participate. You will have huge data. People will take ownership of their surroundings. Let's say, like there are a lot of case studies in India, in other countries, where like people have taken ownership and they had huge impacts on the environment. Plus, once citizens get involved in environmental decisions, the decisions are much faster. You get noticed, the things get noticed much faster, things get monitored or recorded much faster. Plus, it has a huge educational value. Once people get involved in citizens or environmental surveillance, they will talk about data, they will talk about air quality, and this way they will be more educated. Plus you will create future leaders which will talk about environment. They will be your environmental leaders in the future. So a few case studies that I want to mention here. I had like there are a lot of case studies, of course, but I've chosen three which are of different categories. You must have heard about the Air Quality Act. This is a small hardware that allows individuals to collect data of their environment. It can be installed in the rooftop. You get data of carbon monoxide, nitrogen dioxide, and a few more gases. And what happens is you install this data, the small device on your rooftop. Then it has a crowdsourced dashboard. Everyone can see what's happening in different cities, in different areas. So it's basically the how citizens will take ownership, or how citizens take a decision to be more environment friendly. On the other hand, it is the use of technology. There's no government involved, of course, here, but this is one example where, like, this is just one example, but there are a few more similar examples of a hardware which has been installed. Like there is SenseBox, there are a few more. So the governments are not involved here, but this is how citizens make a difference, plus technology makes a difference. Another example which I took was a river in China, which was monitored by 100,000 plus IoT sensors. This is a long river which is like 1400 kilometers, and according to the project director, this is making a difference in 50 million people live daily. Because what it does is it monitors water quality for turbidity, for temperature, for humidity, for a lot of other water quality related parameters. Plus, because this place in China has a lot of earthquakes, they are monitoring structural issues, if there is a structural issue with the canal or the river, and if there are any intruders, so that the water is not contaminated. This is another example where the government took the initiative, invested in technology, and they can easily now monitor a 1400-kilometer long river using the help of technology. There is another example, which is a very famous one, the Great Backyard Bird Count. this was not a lot of technology, but there was an initiative which was like very nicely marketed. So like a lot of people about 160,000 people participated and made a huge difference in monitoring of the bird trends, or how they move around in different weather, right? But just to mention these three case studies, was like there is this one where just the technology and initiative made a difference when there, plus another one where government used technology and it made a difference, plus there is small technology and involvement of citizens and it made a huge difference. Now just how the technology has advanced from like 1998, now a small sensor which can monitor audio, which can monitor air quality, can be installed, and it can do all of this in real time now. The great backyard bird count can be more innovative now, of course. But it is possible with the help of technology, and it has made a lot of impact previously. But of course, it all sounds very fascinating, but there are a few considerations that need to be taken care of. Data accuracy and calibration, one of the major issues when you install IoT sensors. Maintenance is required, of course, and the calibration needs to be correct. Otherwise, your data insights will not be correct. Data privacy, which is very common when you talk about real-time environmental surveillance. Protection of personal privacy is a big issue, and you need to keep a balance between these two. Then sensor placements, they need to be very smartly put in different locations so that the data is very correct and it's not biased. Plus a lot of policies related to quality control and all of that. Of course, it has to be done when you don't have a lot of data, but when you don't have a lot of data and it's manually collected, you don't have issues with quality control checks, because it's very easy. But we are talking about big data, so you need to have correct policies on what data to be collected, what should be rejected. Plus there are bias and representation issues. Let's say if you miss out a few neighborhoods, and then your data is collected, your insights are incorrect, and of course when this data goes to policymakers, it will create policies that may not be representative of all the neighborhoods. In conclusion, I would say that every data that is collected, or every insight that is derived, or every action that contributes to, like every action that is taken, it contributes to a better environment, and it can be done. All of us can participate in it, and we all of us can be the agent of change. Like if you are from technology, you can participate in building those technologies. The government can take initiatives so that people are more motivated to work on better surroundings, better environment. Okay, that's all I wanted to say. If you have any questions related to any of the case studies I mentioned, or any of the solutions that I mentioned, I'd be really happy to help or assist.
Thank you, Zain. That was really exciting. And one of the things to get the questions started, everybody would ask about cost. You gave some case studies, for example, the air quality egg. Do you have any estimation how much, like if an architect wanted to include that, or not as a student project, or a developer wanted to add that feature, what are they looking at in terms of cost?
That's a really nice question. So air quality ag is one of the many hardwares available in the market. I talked about SenseBox. There are a few more, of course. So they have different variables that they monitor, and this cost can be, depending on the variables that they want to monitor. That the cost can be anything from $20 to $70, or something similar. But it can go as low as $20, I believe, for a sensor like this. So it's
And
like
then,
what I'm talking. Yeah.
go ahead.
Sorry. You can
No.
go on.
No, I was going to ask, sorry for interjecting. So compare this to an industrial system where you're having sort of the high-end sensors. Let's say you're monitoring in a factory. What's the difference in price that people would expect?
Yeah. So normally when you talk about industries, there are like a lot of other things that need to be taken care of. Like there are vibrations, there are network issues, then there is like different kind of variables that they want to be that they want monitored. Plus they need their own dashboards. When I talk about public, like let's say when you talk about citizen science, right? So there is one data portal, one central data management portal. So once a citizen want to get involved, right, they want to install this hardware, they just need to buy this hardware. That is all. And that is also sometimes subsidized by the government maybe. But when they want to get involved, they just need to buy this hardware. But when we talk about industries, right, so they want the complete solution. So sometimes when, though the prices of the hardware are a bit higher because they need to be vibration proof and all. Plus they also need this data portal, the mobile apps, the web apps. So all of that together, when we talk about industries, the prices go higher because of this.
And the other thing you mentioned that was very interesting was the government role. And we know you've done work for the government of Pakistan. Could you brief on how they're approaching this?
Sorry, I just missed your question. I had this call.
So when you were talking about what government can do, we know you've done work for the government of Pakistan. Could you give anybody a quick overview of how the government of Pakistan is using IoT sensors or the approach?
Yeah, so like there are a few examples. There is this park where they are growing trees, right? So they are using IoT sensors to monitor air quality, plus to monitor how much the carbon is saved, right? So they have this kind of, this is more of a public-private partnership where this private farm is doing it, government is giving them some resources plus the land to grow these trees. On the other hand, because in Pakistan we have a lot of glaciers, right? We have, I think, second number of total number of in number of glaciers, we are in on number second in number of glaciers. So we have a lot of floods. So what the government is doing is they have installed these IoT sensors on the glaciers, and they do predictive analysis of when there will be floods. Although they are not very successful in this so far, because the policies are not very responsive. There's a lot of corruption and all of these issues. Plus, but they have installed these IoT sensors on top very high glaciers, and they monitor situation there, and they have the idea that the flood may come in a few days or a few weeks. So
That's actually really good, because we've seen the devastation, the flood devastation in 2022 and 2023.
yeah,
And you mentioned early warning networks, and it happened, just so people don't think this is a Pakistan issue. The same thing happened in Maui. The sensors were there. They captured the beginning of the wildfires. Somebody didn't issue the alarms. So the human coordination is just as important as the data, because a lot of lives were lost in Maui needlessly.
yeah.
Another thing you mentioned was, and there's a question in the chat, but you had mentioned about using AI to identify unexpected relationships between variables. Any insight on that?
Yeah, like I can give you, although like not related to environment, of course, like when we work with AI, we get these unrelated relationships which we have never like thought of. But in relation to environment, of course, I have not been part of like some huge government initiative or anything which has like a lot of data coming in with diverse parameters. To give you an example, but it is really possible. I have been part of a few projects which are not related to environment, but I have seen this happens. What my point is, once the governments get involved and it is properly marketed and people do take ownership of the project, you will have a lot of data coming in, and you will see these relationships, and you will see the difference that it will make.
And do you program the AI, or do you use Chat GTP and let it look at the data?
No, because this needs to be in real time, of course. Although ChatGPT has changed a lot of things now, and it will change in the next few months. You will see a lot of change coming in. But yes, when the data is coming in real time, you need to make these data pipelines, take decisions on time, and decisions need to be like in real time. Some of the decisions that are taken on the microcontroller inside the hardware, where like the IT sensor is actually taking decisions sometimes.
And the last question we have from Charity, can we capture the deterioration of buildings? Chemicals react and start causing oxidation reactions, and carbon dioxide being one of those gases and other emissions. Can we capture that? Do you know, have you seen any projects where we're capturing that using IoT sensors?
IoT sensors doing like monitoring chemical reactions, not so far. Although it must be possible, but I have not seen it.
Okay.
I've not been part of any of the such projects, but it sounds really interesting. I'd love to be part of something which does this.
Okay. Elena said the same thing yesterday. So we now have two researchers wanting to work on this. Let's see if there are any more questions. Yes. Which approach or tools are used to translate the science behind the monitoring in order to catalyze meaningful citizen participation? So you capture the data. What tools do you use to get people to engage with the data?
So really depends on what kind of data are we talking about. Normally people like I would say that I have a lot of ideas that I wanted to work on for this, because I have seen this dashboards which people do get involved, but you are, those are not very gamified ones, does not provide a lot of options. But of course, when you do a huge project like this where you want the citizens to get involved, apart from the simple dashboards which allow them to see what's happening around, you should allow them to play around with data, like something like Power BI, or something like, let's say, if there are 50 trees in the surroundings, right, and people can see the air quality around is uh, whatever percentage it is, whatever ppm it is, and there are this number of cars go through in the week that goes through this road, right? What if if I plant 50 more trees, what will happen in the next 10 years? They can be able to play around with this, or they can be able to see this difference. That will make a huge difference. I believe these dashboards, which are simple so far, needs to be gamified and should be on the mobile phone, so people or students or children can play around, and you can ask them to, like, let's say you can reward them based on the number of trees they plant, and they can actually see the difference, that in 10 years your surrounding will look like this. Right, you see what I'm talking about. So it can be more gamified to catalyze. So far nothing like that has happened, but on the game side, on the mobile app side, it is there, people do this, but on actual implementation it's not yet done.
I know UN Habitat has been using, there's a game in the US called Sim City, a simulation city.
Yep.
And UN Habitat has started using that for allowing people to sort of move things in the city, physical objects in the city around. It'll be interesting to check if SimCity can take IoT data, and you could play around with emissions data in SimCity.
So the games have done it, but there is not yet any connection between a real environment and the gaming environment. If that is made, that will be really, really amazing.
Yes, absolutely. So I think we've reached all the questions for you. Thank you so much.
Thank you so much. Really, really nice talking to you.
Yes. And I know you have a busy day, so we really appreciate.
No, it's okay. It was really, really nice being part of it.
Thank you.
Thank you so much.
And before we bring Sebastian on, there's a question here. What are safe and sustainable alternatives to endocrine disruptor chemicals found in paints? So on that, we have bio-based solvents. One example in the UK, I think it was, I don't know if it was Ireland specifically or Scotland, where they were working with beetroot. So you can make sugar from sugarcane, but you can also make commercial sugar that you have on your table from beetroot. And they were taking the waste skins from beetroot and creating paint solvents from that. And that would be a very viable alternative to the sort of synthetic risky chemicals that we have. Of course, the challenge with all of these is testing the manufacturing capacity, the ability to produce that at large scale, and also doing the stress test, the time series test. How does that paint look in 10 years, in 12 years, in 15 years, and making sure that we keep the quality of the final material that we're used to. But yes, there are a lot of bio-based alternatives beginning to crop up. On the flame retardants, removing bromine also tends to reduce the problems with the PBDEs. You now can find bromine-free flame retardants on the market. They're commercially available. So people are finding ways to do that. With the removal of asbestos, heating that to 12,000 to 15,000 degrees Celsius, it changes the composition from into sort of more glass substance, and the danger of the asbestos then is eliminated, but it's not exactly a low energy. So it is a method. You have to use some chemical solvents in that process as well. So there's different ways to handle that. The tricky part with asbestos is the removal, whether it's in roofs or we're finding a lot in curtains, in flooring, in floor tiles. Those are actually more dangerous than the roof tiles because they break easier, they're move around a lot more than the roof itself. So those are things to think about. And with that, Sebastian. Can you hear us? There you go.
Hello, hello.
Hi.
Hi. Doing good?
Yes, you're good.
Very good. Very good. So I'm ready. Whenever you want me to start. I'm just.
Oh, sorry. I have to make you sorry.
Oh.
Yeah. There we go.
Okay. All right. Hello, everybody. Hello, Cecilia. Super happy to be here with you today.
Yes. Thank you. Thank you for joining us.
Well, then welcome. Should I go straight into the presentation, Cecilia? Or...
Yes. Yeah,
yes?
Go ahead. Yes.
All right. Okay, very good. Okay, so let me share my screen. So share here. And here, share. Okay, let me know when you see my screen.
Yes.
Yeah, it's okay?
Yes.
All right. Okay, very good. So, hello, everybody. I'm Sebastian. I'm the co-founder and CEO of PosterLab. What is PosterLab? Is a platform that is helping innovation partners to collaborate together. So basically helping them to structure and scale up their collaboration. So I'm going to quickly explain you what we do, and then I'm going to focus on some of the thoughts that I would like to share with you. I get your point of view about. So let's go straight into what we do. So PosterLab is a startup. We are based in Germany, and our whole idea was, let's say, what we found out is also based on my background as innovation manager for large US and German companies, and I've seen collaboration in R&D as the most complex things to implement and to execute, but on the other end, the most rewarding when done right. And you have pretty good this example from biotech, which is actually located here in Mainz where we are. It's once you pull, let's say, resources together, you can achieve great goals that are beneficial for the whole society. And this is the kind of benefits that you can get on the business side, not also talking about all what we've known in terms of the vaccine. So if partnership done right can change the world, the thing is that it's super mega complex to do. And there's about, let's say, 2/3 of the partnership in R&D that are failing. So it's bad, let's say, for the whole world. So waste of resources, waste of time, and loss of opportunity. So what did we do out of this? So our goal is that we run about, and we still do, interview R&D senior leaders that are into large organizations, as well as SMEs, as well as NGOs, and as well as academia. And what we have been trying to understand is what are the success factors of R&D collaboration? Success factor being, we have an idea, how to execute this idea and to go to market, preferably in the fastest, cheapest, and best way. And we believe that in today's world, this is the most important thing, is to bring, let's say, brain together, bring knowledge together, and accelerate innovation by collaboration in R&D. So how can we enable these organizations that decided to work together to actually execute on their goals? The first pillar, and what we've been asked a lot when we run these interviews is, Sebastian, we would like to have a pretty good understanding of our actual innovation partners ecosystem. What does it mean? Is that each organization on this planet has innovation partners. But somehow these partners are maybe known by one person, more or less, and the other team knows that they have some partners, but they may not know exactly what are the capabilities of these other partners. The problem becomes bigger and bigger, the size of the organization or the size of the NGO or the type of academy. And if you want to collaborate, you need first to map your ecosystem of partners. What are their capabilities? What do they know? What did you do so far with them? And to have this ecosystem of innovation partners accessible across your organization. So not only your employees, but also your partners. From that moment on, where you have, let's say, a player, then you can work with these players. You can pull these players all together, create team across organization, and bring them in some kind of a co-working space where they are going to be able to see what are going to be the different workflows to bring their idea to market. So what should be the legal workflow, how to test hypothesis, what is the technical feasibility, what is the business case, and all in these given co-working spaces, so they all know how to execute on their collaboration. Usually these things is lost in translation. You have some pieces into a PowerPoint, some pieces into Excel, some pieces into Teams. It's super hard to really structure and scale up collaboration in a systematic manner. And this is what we want to solve. For sure, you have reporting, and we make it super easy to adopt. Some of our customers, and even more than customers, these are people that help us to co-develop PosterLab. So we've been working with Enkel, BASF, ZEISS, CSTI, Alikin, and others to really help us to understand the pain and what should be the best way to really structure, let's say, co-working and collaboration. So let's say our view on all of this is, I think, Cecilia, it comes to you. This is one of the greatest things I learned from you. And each time I listen to you, I learn something, by the way. It takes a village to succeed. And, you know, I've been looking around and said, trying to kind of list down all the stakeholders you need to have to tackle a global problem. And this is a big list. So this is a list on your right. So you have the government, you have the private sectors, the academia, the NGOs, financials, locals, and so on. So if you really want to be serious at this game, that is a global game, it's not a game, I mean, it's much more than a game. If you want to be good at this and really solve problems, you need to identify your stakeholders. And you need to identify who is going to bring what into the equation to make it successful. And back to PosterLab, this is all why we designed PosterLab, is to make it super easy to bring all these partners together into a defined co-working spaces with all the workflows that each of them is going to work with. So that's super important. This is how we design PosterLab. The thing is that when you bring all these forces together into a cross-organization collaboration, you need to agree on KPIs. So I'm not going to talk about the usual KPIs because everybody knows them. What I've been trying to bring to this discussion today, and I'm very looking forward to your questions, I've been trying to come up with some kind of global KPIs. And for sure, emission reduction target is clear for everyone. But I was more interested in the two others, behavioral change and global cooperation. I think behavioral change, I'm not deep into this topic, but I think it should be great to have, whenever you bring an innovation to market, you expect people to change. I mean, you expect people to change their behavior or to change the way they were doing things. So I think one of the way, aside of numbers, of sales, of units of economics of being sold, I think it's what it could be interesting is how did actually the people change the behaviors. And I think it's interesting to know because you want people to change. So we should have some kind of a KPI that is actually chasing or monitoring the kind of behaviors you see. People talk a lot about these things in the circular economy. Okay, people need to change, people need to stop, people need to do all these things, but do they do this actually and also across supply chain? And global cooperation. So this is another KPI that I would like to see is how can you capture the forces at stake through global collaboration. Just some food for thought. I don't have the solution, but I do believe that these KPIs should be in one way or another into every collaboration that you may have across the world, especially these days. I would like to bring also something else that could be interesting for the audience. And actually it's kind of in line with the precedent presentation. Maybe some of you are familiar with this thing, but in Europe, there's the EU Data Act that has been implemented recently. And the whole idea about this EU Data Act is to provide transparency across different industry supply chain. What does it mean? Is that within the circular economy, Europe wants to be able that every user of a good in the European market space, whether it's in an individual company, should be able to know what is inside this product. So one thing that they decided to do to promote is what they call European data spaces. So these are kind of sit as a repository per industry where all the players of a given industry will upload their data. It could be IoT, so coming from the production, could be about what kind of materials was incorporated into the manufacturing of a given goods, and so on. So they want to put all this data together into manufacturing, to spaces. So you see this, these are all these spaces. And I think this is, I'm a pro-European, but I think it's a very great idea to pull, let's say, this data together and making it, because it's open space, not open space, open data, meaning that the data, you cannot see if it's company A, company B, or person A, person B. You have access to the data, and from there you can build new business model, innovation, because you have access to a huge amount of data. And at the same time, the whole value chain knows what is being incorporated into the manufacturing of a given goods, which is super important. And to give you an example, so this is Catena X. Catena X is one of these industrial data space. It's the one for the automotive industry. Automotive industry, at least in Europe, is under huge pressure to be much more transparent and to satisfy to circular economic goals. And this whole this putting of data together, ensuring traceability of any information or any product of the good. So why I'm sharing this with you today, because coming back to the main topic of the Africa summit that we have this week, these are the kind of practices that I see in Europe. I don't know if something similar is being done in Africa or in on other continents, but I very much the idea of putting data together of a huge industry into one space. That's the thing. Having this data accessible to everyone. And I think this degree of super high collaboration within all the other players within the supply chain is some kind of a great thing that could potentially help to solve some of our problems. So I just wanted to bring it to you today. Hopefully it's interesting. That's more or less the end of my presentation. I wanted to give enough room for Q&A. Again, Cecilia, thank you very much for inviting me today. Great pleasure to exchange with same-minded people, and I hope it was of added value added. If you want to reach me, you have my contact information. Thank you very much, everybody, for that. Appreciate it.
Thank you, Sebastian. And this EU Data Act is extremely powerful. And I can tell you, so in Kenya, there's the UNFCCC, and there's an initiative to start doing greenhouse gas inventories on an annual basis and by industrial sector. Just to contextualize for everybody what the power of what Sebastian just said, when we initially tried to get companies this was about 2 years ago, to just start sharing that type of data. They didn't want to, because when you're in industry, if you start noticing a change in energy consumption or emission, that tells your competitor what your production schedule is like, and they can counter. And there was a lot of sensitivity to your point about data privacy. So there was a lot of reluctance on an individual basis to share. What you're explaining is something different, that it goes into a central repository, the data is anonymized, and what we would be able to then see is the sector or the combined effects, so that there's no traceability to the activities of one company, but you still get enough of that meaningful interaction to see. Like, for example, if we start seeing that the Syokimau area in Kenya, which is the industrial area, if nitrous oxide emissions start going through the roof, the government can then go behind and start figuring out, is it the chemical plants, is it the cement factories, who's causing this? But we have that general data available. So I think that's very powerful.
Yeah, no, that's why I wanted to bring it. And Catena X is a concrete example of a given industry doing this across the board. All the big players are doing this. So yeah.
A question I know. So one of the things we've been really enjoying the Postal Lab platform. In Kenya, we have a lot of SMEs, and by that it would be companies that probably have 50 to 100 employees are on the big side, and their revenue model, their annual turnover might not reach the 50 million euros or that volume. Some do, but a lot don't. So what is your experience in terms of companies of that size engaging in Postal Lab? What do they tend to come to Postal Lab to do?
So usually the kind of company, at least on a European basis, and maybe because it's a European mindset, but the SMEs, we are more, let's say, serving the larger companies. So we are more serving the larger group, which have hundreds of innovation partners and projects with them. The smaller companies in Europe, in the chemical world or packaging world, are kind of still reluctant to be involved. I mean, some of them do, but not enough involved in collaboration in R&D. And because one of the main reasons they tell me, because I've interviewed them, they tell me, okay, we know we have a couple of partners, we know them, we don't need to know more, just to make it short. I think it's a European bias, which that's why I'm saying this, but I do believe that if you are any other company on this planet, it's very important for you, let's say, to stand out, given the level of competition and the level of innovation complexity. You really need to make a case for yourself. And I strongly believe that in the R&D world, you need to be able to explain in a business way what is your technology or R&D expertise. And from my point of view, this is why I deeply believe that Postal Lab also can be used and is used, but it's not a core business right now, by a smaller company, because they finally find a way to structure, let's say, their findings, their projects, their R&D project in a manner that can be easily, let's say, pushed toward any other innovation partners they have within their ecosystem. So to give you a quick example, let's say you have a company that is part of an ecosystem that would like, let's say, to highlight the discoveries that they did. They can easily invite anyone on this planet that they believe can can close a gap into their Postal Lab space, and they can actually see what kind of information has been covered, what kind of project is run in a structured way for these other partners to actually assess whether or not they would like to collaborate with this company. So for me, it's you have marketing, which is about the branding. For me, what's important is about being able in today's world to be a partner of choice. And being a partner of choice for me in today's world is super also important, but it's not, you cannot you cannot play the same game as in marketing when you want to be an R&D partner of choice. It's different ways to do this. And this is where we play.
And then partner of choice. So one of the things that we have is a desire locally in terms of increasing circular materials. That is a desire not only from government, but also practitioners and the community in the construction industry. Thinking about the level, like that slide you had where you had the number of stakeholders engaging. I think that was very telling. For example, the architects might want to know the availability of the structural material. The government, of course, is looking at regulatory compliance. A multinational coming from Europe might not even know the type of and volume of material to decide whether or not they should make an entry into putting up a circular materials facility here in Kenya. Looking at all those workflows, would you say, my bias is yes, but just from you being the product owner, that having these discussions in Postal Lab prior to an actual engagement contract, it would actually save research time for all entities?
Yeah, exactly. Because I mean, back in the day, I was involved in a lot of R&D projects with several shareholders, and you would have communication across emails, and that was very hard to track. So especially when you start talking with, you have an idea, you bring some partners to the table and you start to exchange, it's very fuzzy at the beginning. So you have a lot of topics that you need to tackle. You need to have to tackle the legal aspect, the technical aspect, the production aspect, the business aspect. I don't know how many aspects you need to tackle. And this, so then PostLab can be easily leveraged, because when you set up, let's say, your space inside PostLab, you start to invite the different stakeholders, and then you are going to invite them to a specific workflow. And only the, let's say, legal workflow, you are going to bring the legal guy to the legal workflow. Into the technical things, you're going to bring the production guy. So they will have their digital co-working spaces for this specific topic, avoiding to have emails flying all over the place with people in CCs or PowerPoints that are out of date from the moment they are done. So you can have this co-working space where any information can be uploaded and discussion happening in this given space. So I do believe that is helping to streamline the conversation at the beginning of a collaboration. And also for the management, at the management level, let's say you are the innovation manager, or you are the responsible project manager in the NGO, or you are, let's say, the professor in the academic world. You can have this overview of all the workflow, and you see at which stage they are, because it's a Kanban-based system. So it gives you the clarity you need to actually decide what should be the next step into your collaboration. Okay, we are mature enough, let's sign an NDA, or let's sign an MOU, or you can really see where you stand, what should be the next step, and put your resources in the right direction. That's my point of view.
And you following up on that, in the beginning, you mentioned 2 out of 3 partnerships fail, and you know that it's worse than the divorce rate for humans, right?
yeah, it's very bad. It's very bad.
Can you talk a little bit about, you have a workflow that is linked to ISO 9000 standard for improving the workability of partnerships.
Yeah.
And Kenyans, there's a lot of companies that embrace ISO. So if you could talk a little bit about that.
Sure. Let me try to share my screen so it's better to show than to tell. Give me 1 sec. Sure. Demo here. Loading. Okay. Yeah. All right. So let me share my screen now. Share my screen. Share. Okay, should see my screen now. So back to where you were saying. So there is a dedicated ISO certification, which is about managing cross-organization collaboration. It's the ISO 44001 that I highly encourage you to look at. You also have some kind of similar things, but with a different angle from ASAP, ASAP, Association of Strategic Alliance Professionals. And you also have another thing that you should also look at if you're into collaboration, especially with academia, which is UIDP. UIDP is a US association that is helping to foster better collaboration between corporation and academia. Really encourage you to look at it. But basically about the health of the partnership, or to assess whether or not you're on the same line, you are sharing the same goals, and each partners have, let's say, skin in the game and interest to proceed. You have these stages. These stages, they say 1 to 11, is basically a summary of the key things you need to have at bay when you start in the process and when you end a collaboration. So whenever, again, this is a space where, from a perspective, let's say it's a given collaboration in a new packaging, for example, and you have all the parties that have been invited to this space, and all the parties will have access to. This is going to be the way we are going to assess the strength of our collaboration. So you see this workflow, partnership health checklist is actually one workflow. And this is the stages and the point that are going to be actioned. So it means, first thing first, you decide to work together, very good. What is your mission? What do you want to achieve? What is your expected ROI? You would see that some partners are expecting different ROIs than you do. What are the key people, the skills? Because if you partners, is obviously because you need to leverage each other's skills. What is the organization profile? What should be the metrics, peer metric, especially how you manage to escalate things when things are not going smooth. You need to have a steering committee. Without steering committee, forget about collaboration. That's very important thing. So all of these steps make it super easy for anyone that starts the collaboration process or has some experience into collaboration process into a kind of a backbone to put, let's say, to increase the odds of success of any collaboration.
And could you show them also the dashboard so they can see?
Yeah. So dashboard is another parameter. So here in the dashboard, you can let's say find out who are your main partners. It could be important because let's say you have an organization that have many partners. You need to define who are the strategic ones that are core to you and that should maybe be closer in terms of nurturing. You can see, or let's say, your core partners and how many projects you have with them. You can see how many, let's say, what are the numbers of action by department, the budgets. You can basically do any kind of dashboard you need on a space level. So space level meaning you have a co-working space, you have different projects, or at the portfolio level or at the project level. It's up to you what kind of information you want, depending on the level of, let's say, organization level, portfolio level, or project level. And when I was mentioning just before about one of the key things that is always a struggle into any kind of collaboration, let me show you this flow. So any collaboration means legal aspect. So here again, you have a Kanban system that can be set by your manager or by anyone within your organization that tells you, okay, every collaboration is going to be run like this. We sign an MOU, we sign an NDA, we sign an IP agreement, if any. And see, this is done. And you can see here that everyone that has been, let's say, for example, NDA, you can see each party that have been invited, they have their own chats, so no specific emails, their own chat, you can see the parties, and you can see any information that are relevant to the scope of the NDA. Again, making it super easy to find back the information and to have a space so that the partners, the parties involved into the legal aspect can track, and on and on.
And I saw at the bottom, you also had the approval, the VP of R&D has to.
Yeah, exactly. And you have a log file, which you can also track, the template and the information.
This is great.
Thank you.
I've been asking you a lot of questions, so I'll open up, see if anybody else has questions on what it is that they've seen so far. Anything exciting or any questions you have while Sebastian is here live, rather than, we also get questions as we're using it. We get people sending in questions by email, but this is for those who work with us, this is a time to be able to ask Sebastian live any questions. What, in terms of looking at it from you touched a little bit about academic industry collaborations, and those tend to be fruitful when they work, challenging to set up. One of I'm actually finishing up on my PhD research on that topic, and looking at the alignment of goals. So, and by that I mean, what I like about your Kanban is it has a lot of workflows, and by alignment of goals, let's say we agree that we wanted to make organic additive from waste beetroot, and we wanted to put that in paint. The company's time frame for deliverable and the academic research calendar when students are available and somebody's not falling half asleep during their postdoc or doctoral thesis, or flying to Munich for a conference and forgetting that there's a research pending output that there is needed. So those are the sort of issues that tend to cause high friction, because of course, to your point, you have multiple organizations, and what one is not a direct boss of somebody in another organization. So being able to tell somebody, no, you cannot do that when you're not in that organization becomes challenging. What do you see in terms of looking at the ecosystem? How do people build what I would say redundancy? Because that's one of the issues. Like if you have only one PhD student working on that chemical formulation and that PhD student gets frustrated and quits, the project stops. What do you see in terms of people, what they're doing to build ecosystem redundancy to deal with sort of some of these issues to not get locked in?
Yeah, that's a very good question. Which is, I mean, across the board, I mean, you have turnover on the corporate side, you have turnover in different aspects, you have budget being cut. I mean, you have a lot of changes that can happen in the course of collaboration. So that was one of our axes when we've been talking with the corporation and the other companies to see if it was a problem and how it could be solved. And in fact, let's say you have let's say the problem of reinventing the wheel and losing data, or not having access to legacy information. So you are going to do a same hypothesis again. So the whole idea was to try to digitalize all of this information to facilitate knowledge mapping and knowledge transfer. That was our angle back then. It's not easy because for any digital platform on this planet, you need to have a huge adoption. You need to have a critical mass to make this work. It's not easy. At least from our side, we try to minimize we try to apply the 1=3 rule, which means that if you put one data, you need to have 3 outputs to kind of increase the usage or the adoption of the system by the researcher. The researcher were our primary goal. And we also, with the 1=3, we also used NLP, machine language processing, natural language processing, sorry, which would ease their job. Because one of the issues with early research findings is that you are writing a lot of papers, you are writing a lot of things, but these are usually not disseminated to a larger audience as they should be. So what we developed, one of the first features we developed is we developed a system that can extract information for a given scientific poster, for a paper, or anything that is academic related. so that they don't have to do it themselves, which is facilitating the dissemination and the adoption of the platform and dissemination of information. So the idea is super uploading you upload the scientific poster, and the system will extract, make a summary, extract the key topics, extract the keywords, and allocate this information to the authors or the co-authors, which is directly mapping the knowledge with a person. Because I'm definitely convinced that the knowledge is a bundle of a person, a person and a document, right? So this puts this all together. So that was one way to articulate to increase the chance for having data in the system. And once you have data in the system, somehow automatically you are, let's say, optimizing the chances that even in the case of a turnover, information is not lost. That was our input.
And I've actually used that function, not for uploading research paper, but we were working on getting our research ethics protocol up into Postolab. And I was able to take a PDF that had a lot of stipulations, and it was 3 in the morning, and I didn't want to think about how to take 5 pages of research ethics stipulations and turn it into a workflow. And I uploaded that PDF, and out came the Kanban workflow, and I was like, oh, thank God. Hold a meeting to figure out what we're going to extract from this document.
Yeah, it's very helpful. That's all of the things that's, I think in today's world, if you can manage to remove, let's say, negative friction, being having to write down things or pass over things, for me, this is also about having a very smooth and logical process, minimizing any negative friction to pass over the information. Because for me, information is the most important things we have on this planet. So it should be super easy and natural that this information flow. And this example is one of the ways that you have your meeting, you have your documents, automatically you have your task. Anything that can accelerate the innovation process is key.
Wonderful. So I think with that, I'm not seeing any other questions. But hopefully this has been wonderful for everybody. I know I've really enjoyed, we always enjoy chatting with each other. And thank you for bringing this Postolab platform, not only developing it, but taking time to explain to our audience what they can do with it and how they can interact through it. We'll be using it as CSTI for our collaborations. So we're definitely trying to, as Sebastian said, become the R&D partner of choice for a lot of different organizations. And for those who are working with us, we look forward to helping these collaborations succeed. So thank you very much.
You're welcome, Cecilia. Have a great day, everybody. Take care.
And with that, we're coming to the end for today. We have 10 minutes left. Wanted to open up if there were any general questions that you're interested in having answered, or any general issues that you would like to discuss. We've covered a lot of ground. The reason that we're doing this side event in 3 days over 2 hours a piece is that there's a lot of technical data, as you've seen, that we're trying to cover. And in previous sessions that we've had, we've been told nobody survives a full day conference of CSTI information without getting exhausted. So we're trying to break it up in chunks to make it more palatable, and also segment different interests. So for those of you who are working on data collection, that was the goal for today. Professor Wandiga will not be able to join us tomorrow. He has some functions that he has to do, but we'll have Rusa Munene from our board doing the opening discussion and introducing the topics. And tomorrow we'll focus on what the theme for this conference mainly is, which is the green finance, and looking at ways to take all of these activities and align them with green finance and start to see what is it that we have and what is it that we're missing. I know the data, and especially big data, is a critical part of unlocking finance. So hopefully the information you have today gives you more ideas on how to pull that big data together. And with that, I'm not seeing any other questions. So I will invite Professor Wandiga to do the closing remarks.
Thank you all for being with us up to this point. Data is the key, data is the issue, and how to gather data, manipulate data, and extract information from data is what we have been talking about. We have also been talking about collaboration between individuals, between countries, between companies, and making sure that collaboration is sustainable and useful. This is an area that I wish I was younger, I would have entered into, but it is open to the field, and I invite you to join with colleagues who are doing work in this area and develop and move the frontier of knowledge further. I hope that we will hear from you, get information from you, and get questions from you about this area. Thank you very much. Have a good evening, good morning, or good night.